Now let's come up with a general way of looking at this multiplication rule. I may not just have two outcomes. I may have three or more outcomes. Suppose the probabilities of these, three or more sequence of events. I have sequence of events, one happen after another. Maybe in real life happening one after another. Maybe just a sequence in which you choose to analyze the problem. So if I have the probability here 0.3, here 0.4, here 0.7, at the end what do I have? I have A, B, C, which means all of them happened at the same time. Yeah, so to get this probability is simply to multiply all of these probabilities on the branch that lead this outcome. So it's 0.3 times 0.4 times 0.7. So you're just multiplying. This is what's called multiplication rule. Yeah.
This probability of A multiplied by
Yes, exactly. This is the probability of A. Yes.
multiplied by probability of B given
Very good. This is B given A. Exactly. Perfect.
C given B.
And this is, I'm just going to, this is the probability of C given B, if B only happen in one time, but if B happen again in different part of the tree diagram, it is safer to just say AB, because what actually happened at this point is both A followed by B, right? So you can write B, but it's better to write AB because maybe there's another place will B appear. Okay? So, but the main point is that it's always after that conditional property. So this is conditional property. This is conditional property. But here, this is simple probability. And everything after that becomes conditional until you reach the outcome at the end. And the outcome is a joint probability of all of the sequence happened. A happened, B happened, and also C happened. So this is the main idea of the multiplication rule. Yes?
I didn't get the probability A, B.
These are just theoretical examples. This is not, A doesn't have to be something. Just A is anything, something happened, and then B happened after that, and then C happened. Suppose A is the probability of rain. The probability of rain today is 0.3. And B is the probability that you will get the full mark in the quiz. And then C is the probability that you will go to the movie tonight. So what is the probability all of them will happen at the same time? You just multiply them. Because at the end of the day, you went to the movie, you got a full mark, and it was raining.
Yeah, but do you think that you wrote conditional and simple?
Yeah, because this is, because in general, the examples I just said are just some of the examples, which probably don't depend on each other. But in general, this B depend on A. So the probability of B given A happened, maybe the probability that you get the full mark if it's raining is different from the probability if getting the full mark if it's not raining. Maybe you don't like the rain, for example, so it affects you somehow. Or maybe it's opposite. So in general, B happened after A, probably it depends. So we say B given A, because that's not any B, that's B given A. All right? C depends on also what happened before.
But B doesn't depend on A.
B does,
depends on A and A doesn't depend on anything.
Yes, A does not depend on anything, exactly. Because this is what happened first. At least this is the way of your choice of the analysis of the problem. Okay? We'll see other examples of dependency and independency, but this is the general rule of the multiplication rule.